So welcome students to our week 3 laboratory works. So today we will practice arrays and pointers. So pointers of course can get slightly tricky. So let's see again, we have our week 3 assignment. So you have a small quiz again, 10 questions on basics, on theory, but the practice is here, lab 3. Let's open it up and look at instructions. So there will be very similar, the approach will be similar how we did it in week 1 and week 2. We continue using my repository, and the only challenge will be how do you get the assignments in. That's one of the challenges first. So let's go through that. So there will be 3 files. Lab 3 task 1, Lab 2 task 2, Lab 3 task 2, and Lab 3 task 3. Again, as usually, you will have to fill in your name and student ID, and all the functions are already set up for you. You just have to fill them up. You have to finish the placeholders. Okay, so let's look at the repository. So here, right, so the files live here, right? Source folder. Again, you could go one by one and copy paste them as well, by the way, right? These are the tasks, right? But of course it'd be much more professional if you could update your own repository with my changes, and then you could work in the code space with the new changes. So that would be the better approach. So I'll show you again how to do this. So again, you open a code space. You probably have already code space. If you don't, you can just start one up, right? You have plus, you can make a new one. You can delete the old ones, it's fine, right? So I'll open up in a new window, right? So now let's see what else is needed. So it's starting up the code space, takes maybe half a minute, maybe 2 minutes if you have a completely new one, right? So the main difference between your code space and mine is that I already have all the assignments, right? 1, 2, 3, right? So now, how do you get there? Well, so there are a couple options. There are actually 3 options to do it. Right, let's go through them one by one. So we need to, you can update, so git checkout main. This is not really necessary, but you can double check, right? It will say it's already, yes. So that's fine, just double check, nothing happens. Right, so now you do this following command, git remote v, right? Here, on. Notice I only have 2 lines because this is my original, not yours, right? But you should be seeing here 4 lines. You should be seeing origin should say your name here, right? And you should also see upstream. If you followed last week's instructions, upstream should be something like this. So your name here and upstream here. It should be actually 4 lines. Fetch, right? Fetch and push, actually, both, right? Again, you're not going to be pushing to my repository, you're going to be pushing to yours repository. So, if you don't see my name, you do this git remote, this following line. To me, this would be useless to do because this is already my repository, right? So, once you've done it, you will do git pull upstream main. And this will pull you do it here, right? No, sorry. Control V, no, Control Z, right? So yeah, I can't do very well with the git, right? That's what you do. The same as actually with PWL. It's a command line option. So now there is, if this somehow you don't feel comfortable with command line, right? There is option 2 or A2, which some students discovered last week, which might be better. I don't know, might be easier for you guys. And I'll show you an example using another repository that I have. So this is different repository. You don't have to worry about, don't have to remember it. Actually, it does have some tutorials in C, which is not my original. I forked it, just like you did mine. I forked it from somebody else, just to show you the example, right? And what you will see, if you go to your repository, you will see you are behind somewhere, right? You will see you are like couple commits behind. You can click the sync fork. This is like this might be easier. So if you do this and then you open up your code space, right? You open up your code space. I don't have one here, of course, right? So because this is just a bunch of information. This is just links to other programming tutorials, right? But anyways, so you sync fork your repository right? Here, because of course I don't have a fork here. I don't have a sync fork button here because I'm already, this is my original, right? But you will have a sync fork button. That might be easier. Then you open up your repository and all you have to do, right? All you have to do is git pull origin main. So this is a great option, I think. A2 might be preferable, right? And notice, it will actually, if you don't have any, you have some new changes, it will actually pull these changes. In my case, I'm already up to date. I have all the files here. All right. So if something doesn't work and you don't want to, you're having trouble troubleshooting, maybe it's GitHub is letting you down, right? You can do option 3 or option B, right? You can create a new fork. Right, it's not something I recommend, but it's possible because you'll have to, you know, if you do it every week, it's kind of pointless to. Then what's the point of Git, right? Basically, to do a fork all the time, right? So maybe it doesn't work. You feel it's like completely beyond repair, right? It's not the end of the world. You can start a new life, right? So what do? You basically fork. Let's go to some repository. Basically, you fork, right? To me, I don't want to fork my own copy, right? But you would do a fork, and then the only thing is, you have to probably rename it, called version 2 or week 3 or something like that, right? It'll have to have a different name because it's your student name, right? Your GitHub student name, and you know your original fork may be messed up, but you know you don't want to, you can't really overwrite it easily. You have to delete it first, right? And that's fine. And then you go to your fork, right? Remember again, it will be something like your student name and maybe like week 3 here. And again, you start the code space, right? Create code space. And you have everything here. Unfortunately, you won't have your homeworks from the previous weeks, right? Those are in a different repository. That's why I'm not recommending it, right? They'll be all spread out, right? Not recommended, but it's possible, right? If you want to go every week, have a different repository. I mean, it's only going to be 5 repositories, not very professional, but it's possible. I'm not going to, remember, it's not being graded, so you don't have to worry about it, right? So, but now assume you have successfully used one of these options, right? You have one of the 3 options, one of them worked, right? And now we can look at the files. There are 3 files, 3 tasks, basically 3 tasks. And I think they are in the order of difficulty. So let's go slightly again. So there is a array, you need to do some array functions, right? Minimum, maximum, sum, and average. Easy stuff, right? You just need to remember your array math, right? Easy, you know, zero-based indexing, just like in Java, just like in C++, right? Easy stuff. Just to get you, so how to say, get started, right? So you just fill out these. So, how about task 2? Task 2, this is where it gets difficult. Right, if you not dealt with pointers before, again, I know some of you took Java, some of you took C++, right? If you took C++, you'll be fine because it's just the same thing, basically, right? It's actually a little less work, there's no reference, there's only pointers, basically, in C, right? C++ has more stuff. In Java doesn't really have pointers, it hides them from you, right? So you have to do some practice. There's only 2 functions, exchange values of 2 integers using swap, when you pass 2 pointers in, right? And also modify function, which actually should be really called double the value of whatever x is pointed to, right? Because we are giving, remember these, what is this syntax? If you seeing this first time, these are memory addresses to integers somewhere, right? These are not the values themselves, right? So good practice, good first practice for these 2, right? And let's go to the hardest task. And you might not be able to finish today in class. Maybe we'll do it later, right? Again, it's good practice, right? And these are actually, well, they're not that hard. I mean, again, if you've done any pointer work before, right? So string length, you're giving a string, and basically you're implementing a C function, which already exists, right? Basically, to return how long is a string. And remember, in C language, strings, these character basically, they are basically pointers to characters on with a zero, with a terminator character at end, right? So kind of a bit tricky. And I think the hardest task today is my string copy, right? So this is basically you giving a destination, right? So this is a terminator character, by the way, right? Count characters until this is 0, basically, right? On 0 byte. I mean, so you're given 2 pointers, right? And you have to copy, right? So this, of course, is extremely unsafe, by the way, function, but this is good practice. So you can, in fact, if you do it wrong, you might break your virtual machine here, right? I should probably add an instruction here, right? This could go wrong, that's okay, right? You're here to learn. If something goes really bad here in this task 3, I recommend maybe you just delete it basically, right? Restart the machine, restart the code space, right? You can remember, you can always here, you can restart, stop code space, and restart it basically. That's fine, right? If you think something, there's a crash, right? And you think something is not good, not working well. So this, of course, is a very unsafe operation if you were working on a real machine, right? In old days, this was very dangerous, right? That's why C is a dangerous language. But of course, you're on a virtual machine, you can't really destroy anything else, right? You're not going to destroy a Microsoft server by or going somewhere where you should not be. So, I know some of you might be experiencing pointers first, and of course we have a teacher which talks about these topics, but if you want some extra resources, I highly recommend the Harvard CS50 course. This, of course, is probably the top university in the world, right? And this is what they teach, and it's basically what we teach, of course, but, well, the teacher there is, I think, is probably one of the best in the world, and very, very good. So if you have some problems, but again, there's a resource to this YouTube link, right? Very good resource on pointers. Again, if you're experiencing pointers for the first time, maybe I'll add some extra resources as well, but this is a very good resource. So again, what do you submit? So let's go back into the instructions. Where's our instructions? So you have 3 tasks, there's some examples, and you submit, of course, lab 3 tasks C and on. If you have working GitHub link, you can just submit the repository, right, which has your modifications. Don't just submit a repository which has no modifications, it's kind of useless then, right? So that's what you should be doing. Okay, now one more thing before we go, I should show you how to build things. By the way, I updated Makefile as well. Now it's pretty long, right? That's pretty nice. You can do make help, right? You can type make help, right? And it will show you all the different instructions that you can do. So make your life easier. Remember, Makefiles is basically its own programming. It's like a shell programming language, basically, right? You can do all kinds of stuff, automation with it. It's been around for, I don't know, 40 years or more than that, actually, right? Command based. So we can do make all, but we can do make lab 3. Make lab 3, right? This will build all 3 programs. If I do this, what will happen? It will get warnings. Why? You will see this, right? So. Make lab, actually, wait, I need to remake it. Make all? Make clean, yeah, make clean first. Yeah, I destroy all the, and make lab 3. Right, so, let's see what happens here, right? So there's you have your work cut out for you, right? So what's saying, these are a whole bunch of warnings. It compiles, right? It's saying array, remember I'm putting the pedantic flag, meaning the angry aunt or angry uncle or angry grandma who is complaining about all kinds of, and also all type of warnings, right? So it's saying you're not using array, you're not using size, you're not doing anything, right? So you, of course, when you complete all 3 tasks, it will actually be, you will not get any warnings, right? That's your goal, basically, is, right? So you can do it one by one. By the way, you can do one by one. Let's do my clean, right? Make clean. You'll destroy again, clean everything, right? And there should be make just a single. No, I guess not. I think we can build one. Let's see. Can we make make build one? I believe so. I forgot now. Yeah, make lab 3 actually. I think it's make lab 3. Yeah. So again, you can of course use them one by one, right? Again, you can use them one by one, right? And I'm gonna show you last thing. You do it by hand, right? You can do this GCC, right? GCC. I'll do VAL, right? Just single flag, right? And source lab 3 lab 3 task 1, for example, right? Task 1, output, you know, task 1, right? Something like that. On, it will compile, it actually compiled, right? It's actually compiled here. That's how you compile. No pedantic errors, right? That's how you do it by hand, right? If you're not sure, right? And you're gonna run this task now. It'll probably break things. I didn't even check what's in there, right? I don't think I have any. Nothing will happen actually, right? Will anything happen? Return. Oh no. So if I run it, let's say do a task, right? Yeah, it runs, right? But obviously 0, 0, 0. Why? Because all the placeholders are there, right? It runs, but all the you know, we want to get some answers, right? We have 5. We have a small array, 5 size, right? Think about, again, last hint. Think why in C we have to give size, right? This is kind of interesting moment, right? We have to give the size as well when you're doing some array operations, right? It's not so easy in C to determine the size, right? Unlike, let's say, Java or Python later on for you guys. Okay, so good luck. I'm sure you'll do it. And again, it should be a good practice towards our final lab 1 big task. Okay, so see you guys in the lab.